Hello, hello. Can you
Hello.
hear me okay, Jan?
Yes, yes. Okay.
Welcome, everybody, especially the students from IIT Bombay, for joining us today. We have quite a few working professionals in different time zones, and thank you again for taking the time off for a small bit and spending some time with us, me and Jan. My name is Anup. I am the head of product marketing at Pathway, and it'll be a good time to tell what Pathway is about. Pathway is the fastest data processing framework supporting unified workflows for batch, streaming data, and LLM applications. And today we have Jan Chorowski. Jan?
Hello.
Jan
Hello.
Chorowski is the CTO at Pathway. He has worked at different places. He graduated in the United States and also worked at the University of Wroclaw, collaborated with a lot of research teams including Google Brain, Microsoft Research, and Joshua Bengio's lab. Did I get that right, Jan?
Yes.
I know you've done much more than that, but I had to keep it brief. Can you share what were you working on at Google Brain and Mila before we get into the meat of the topic today?
Sure. I was working on applying deep learning to speech recognition. This actually started at Mila. I was there in 2014, and this was the year when they started to play with the attention-based networks for translation, and we managed to make them run for speech recognition. The same attention mechanism that then went on to power the transformer was then developed. The fledgling slate on only one attention per the whole network, no multi-head, multi-layered attention yet. Both for translation and for speech recognition, most of the work I did centered around how to make it reliable for very long sequences. I guess something which is still applicable right now. Back then, if you did translation, the length of a sentence would be 20, 40 tokens, a few orders of magnitude less than the amount of tokens you can put right now into a transformer. And then when we jumped into speech, suddenly it was supposed to do the attention over hundreds or thousands of speech frames, closer to where we are right now. Part of the work was to see how the attention mechanism breaks down in the presence of noise, of long inputs, how to make it generalize for stuff longer, which is somewhat relevant to what the transformers are doing today as well.
Ah, Transformers, the attention side of it, and I know you worked very closely with pioneers like Joshua Bengio. Did you know that these guys, especially Joshua, was going to be part of the trio, the godfathers of AI, or is that something you were surprised when you heard about it?
There were only a few people that believed in the neural nets since the 80s when they were first described with the backpropagation, all the way through the 2010s when they started to pick up again. And that would be Jeff Hinton, who did the backpropagation paper in 1986. His PhD student at the time, Jan LeCun, and then Joshua Bengio. The moment there was this AI winter, the neural nets had a very bad press. The neural information processing system, the NeurIP conference, would be more often than not rejecting papers with neural in their
Mm.
contents.
Hmm.
Everyone was talking about SVMs. And then those three guys prevailed and were doing deep learning or trying to make it work and succeeded at that. It's a very well deserved term.
Nice, nice. And the bad press lasted for how long? Yeah, was it late 90s?
Early 2000s, idea would be that these are very good models, but there were boosting models that worked well, the support vectors or kernelized machines. They will make a comeback.
There you go. I like that positivity. And now we will get straight into the meat of the webinar today with the questions, a lot of questions coming from our practitioners. The good news is we have the GitHub repo on the top left corner. Look at the screen. If you want to check us out, Pathways GitHub repo, please take a few minutes. This is what most of the students who have joined us have also started using and given us very, very good feedback so far. Unless Jan says otherwise, I'm sure I've seen Jan applying to our Discord channel with the variety of applications these students have done recently and also our practitioners. So going to LLM related questions,
Hmm.
from your perspective, Jan, what are some
Yes.
interesting capabilities, limitations you're seeing, which are not really commonly discussed around LLMs?
So for capabilities, I guess everyone is surprised by how well they work and then testing the limits of where they break. A funny breaking point I've seen with some of them was to try to ask them unconventional questions in very conventional setups. So say you very meticulously describe a game and then ask the system to play a losing move. In a sense, the game is won by losing. most of the time they don't get it. Or you start doing a puzzle, but there is no puzzle. So you go with the story of, I don't know, the wolf, the sheep, and the cabbage on the one side of the river, and this boat. And the boat can take 100 persons, and no one will eat anyone. And then it got meticulously described, so you have to move the cabbage and the wolf first, and then get back the boat. And so trying to see where the models extrapolate from patterns of thinking that we have witnessed, or being misled to extrapolate or copy the ways of reasoning that they have seen to places where it's not really necessary. I guess both of these, the losing game and constraint problem are examples of cases which are hard. And when you just match the keywords, you get the hard solution, which is very prevalent. So they are very confusing. Every time you see a puzzle or every time you see a game, someone wants to win it. And if you put it in position, I want to lose at this game, then suddenly it's way less probable.
Got it. Got it. And when you say when these things, these unconventional path or unconventional questions, is it because these models have not been trained around failing? In this example, failing a game, is that why it is, or is that it's just not meant for these low density neural pathways? No pun intended.
I guess it's an open question to which degree these models learn to think and to which degree they are interpolating reasoning patterns they've seen. And on a more philosophical level, to which degree do we think or just repeat stuff that we have heard elsewhere? If you look at spread of information between humans, say on Twitter, there is one guy with an unpopular opinion, and then people start copying him. Who was doing the thinking? The one that put up the idea or the one that popularized it? It's
Fine.
hard.
Fine.
So
Yeah, fine. There's some set of association happening with recency, right? And the recency is happening through that the person who has talked the loudest around that idea. That's very interesting. Just on a side note, and thank you for those who have been scanning the GitHub code. But there's also an opportunity to ask questions as we go through. Jan's touching a lot of topics around LLM, so please feel free to continue asking questions on LinkedIn. You can ask those questions, and what happens? What we will do is we will, based on time remaining, we will choose a few of those questions and ask Jan to give his thoughts and opinions on those areas which you're curious about. So that'll happen towards the end. We'll try to wrap this up in roughly maybe 30 to 40 minutes, and we'll keep some time towards the end. So the questions we've received so far have been thankfully to you, the audience, asking me through LinkedIn earlier, and we've collected a list of questions beforehand, looking at the themes of questions and asking in a much more succinct manner so that Jan can come back with some of his thoughts. Going back to the questions around LLMs, one of the things which have popped up, most of the questions have been popping up around the operationalizing LLMs, but specifically around how you see these LLMs being updated efficiently in the field in response to new data. When you look at new data, more recent data, what are the capabilities you're seeing in terms of continuous learning, adaptation?
So for the LLMs, you can use two ways to adapt them, right? One is to train the actual neural net on new data, which would be called fine-tuning right now, which resembles this more classical paradigm of machine learning. You get a training data set, you do operations on the model, you end up with a better model. The other way in which they work, because they are inherently sequence completion engines, is you can prime them with some prompt to respond to your query. And in fact, this prompt can be quite intricate, as you, I'm sure, as all of the audience knows. And then you can encode into this prompt a little problem and ask the model to solve it. So the one-shot, few-shot learning. And this is also a source where you can inject new data into the network. So suddenly the network is mixing the knowledge supplied by it in the prompt with the knowledge it stores in the weights. And suddenly, if this is your model, then the machinery that both supplies the data into the neural net and the neural net itself, the LLM, they are both parts of one large machine learning model, tuned, if you do prompt design, proper tuning or learning, tuned to solve a downstream task. And then you can design parts of it to be faster than the others. So the update of the external knowledge can be faster than the updates of the weight of the net. And you get some sort of real-time adaptability.
Got it. Got it. And around, like I said, a lot of questions around, productionizing stuff. So what are some guidelines and you would provide to folks who want to productionize LLM apps, if that is a term, LLM apps? There's this whole trend around
Mhm.
mobile apps. Now we have this LLM apps coming in. So LLM apps into production, what are your guidelines? What do you have to do this thing? If you don't do this, you're screwed, is the kind of question.
I would start with do proper logging and understand that the system is really a whole. It's hard to decouple the behavior of a machine learning system into parts. And the reason for that is, let's say that you are doing a very classical RAG augmentation language model. So there are only two parts. One of them retrieves the documents, the other one answers on them. But for whatever reason, your retrieval is broken. It gives you some sort of a document too frequently. And you know it. And then inside of the prompt, you nudge the model to maybe overlook this or to respond slightly differently, right? You have a problem and you compensate for this problem down the line. You do it either by prompt tuning or by babysitting the model, so playing with the prompt until it kind of answers like you want. Anyway, you have fitted the prompt to the data or to some examples that you had. So there is a upstream part of the model. It introduces errors. There is a downstream part of the model. It compensates those errors. Now, let's say someone fixes the database. He says, oh, we were indexing this folder twice. And this is why you were getting duplicates of this data. And this is why there was overpopulation of this concept. So he does
Mm,
it.
mm,
But the compensation down the stream, the one that tries to downplay the thing, is still there.
mhm,
So the model as a whole is working worse because the bug in the upstream processing part became a feature for the downstream processing part. And we compensated this bug because there is no properly defined interface between the two parts. You tune each and every part to play well with each other when you design them. And then, as you see in this small example, it's really hard to make a change in one place and not expect this change to propagate
right.
down the whole system, which
Mm,
means that in order to see what will be the impact of a change, you cannot analyze the parts out of context. You have to analyze them jointly.
mhm,
And this has been a problem with those models for a while. You were asking me, Anu, what I was doing as part of my academic career. I
mhm,
was also working on the so-called end-to-end learning. So trying to have systems optimized, say for speech, from the speech processing part, the acoustic part, all the way up to language modeling and so on. So try to tune the network as a whole, as opposed to tune the model in parts. So you have an acoustic part, a language modeling part, a thing which glues them together, and then you can tune each of those things separately. And for an end-to-end tuned system, or for a system where you fix a part and then tune the other ones, it's non-intuitive because fixing a part may actually make the other part worse,
hmm,
or it doesn't have an effect. You remove noise from one part of the system, suddenly the other part needed this noise. You have those things that the LLM is better when you start the sentence with take a deep breath, or you
which
put
I'm
some
doing right
other
now.
filler thing, right? Then suddenly you decide, oh, I'm going to cut on tokens, right? I'm going to distill my input documents into some shorter form. What if the model works better because it has those few non-information bearing tokens where you can do some computation in the middle? You remove them, the model is worse. So my advice would be treat the system as a whole. Ensure proper logging for each of those parts such that you can analyze them, but don't rely on the assumption that if you add or fix something in one place, it will not affect the other places. It will. It's a system which is inherently tied together, and there is no definition of what's on the interface between the different modules. And this has several implications, right? If there is a database which feeds data into your system, the data in this database is part of the model definition. Because if you
Ah,
change this data, the
mhm,
model will answer differently. So
mhm,
if you want to understand why the model suddenly is answering a question badly, maybe it's I put a bad prompt. Maybe I switched to a other language model provider. Or maybe I changed something in my database and now it's
mhm.
confused. So if you don't try to version all of the environment, treat everything which enters the model as code, in machine learning data is code, then you will have a very hard time debugging or updating the system whenever anything changes.
Got it. Got it. This versioning seems to be a big problem, Jan, on the LLM side, especially on the unstructured documents. And when this concept of change, if you talk about change and versioning, usually a version is supposed to have change. The significance of change is not well defined in document versioning. What are your thoughts around that? If it's a small change in a document, and you mentioned this whole thing, but to treat it holistically in terms of LLM ops, what are your thoughts around that?
For the documents, you probably have a few parts, right? You have the documents which are external to the system.
Mhm.
They are produced by a business unit or by someone else, and we cannot really control them. But we can have snapshots, so we can know what went into our system at different times for quality assurance. And then there is this whole pipeline which takes the raw documents and produces the processed outputs. For instance, if you go from raw documents into vectors, this whole part is under your control. You cannot do the cut at the vector database, which holds your vectors. You have to do the cut at the raw storage of the documents.
Mhm.
And then if something tiny changes in the document, ideally you would want your document preprocessing pipeline to do just a tiny change to the indexes or transformations that is created to it.
Mhm.
It may be trivial if you do trivial things, like for each document you extract text out of it and then try to embed the text, it's okay.
Mhm.
But what if, say, you do pre-clustering? You have documents that they are duplicates among them. You are doing pre-clustering of those documents. And then someone changes a document and it, I don't know, has to go out of this cluster. Writing such a pipeline is not trivial. By the way, that's where Pathway is a help.
Got it. Got it. Yeah, and I think document textual versioning is somewhat discrete in terms of what the change looks like. You can see the change. And when you go into things which are images and videos, which you have also dealt with speech, just adding a new word into a long stream of speech, suddenly it's a new version, but it's a very small, it's a small change. And what does small really mean, right? So these are good questions to ask and find out what does that business mean with change, and what is the significance to that final LLM app you're building. The other one I want to touch briefly on, and I know, Jan, you have quite a few, not just experience, but the research behind it, is mostly around I within quotes, real-timing LLM apps or real-time nature of LLM. We know, for example, ChatGPT, if you go and I think the basic version still has a very clear prompt saying we don't have data after a certain date. What are your thoughts around making LLM apps much more relevant in terms of freshness of data for business consumer-facing apps? What are your guidelines, thoughts around those?
You have to supply this data somehow. The LLM is a tool to process data in this sense. If you supply the fresh data using a prompt, for instance, it doesn't matter the knowledge cutoff in the weights of the LLM, it will be processing the new information. Then maybe you will want to use the LLM in many places as part of a data processing pipeline. Then you use the LLM as a Swiss knife of solving NLP problems that you apply to your data and update the results in real time. Maybe there
Mhm.
is an LLM which handles answering of questions,
Mhm.
but the whole pre-processing prior to it, you treat the prompt as the data and the LLM as a tool, and you use the old tool on new data.
Got it. And in the real time nature, do you see that this whole concept of versioning does matter, or you seeing it's less prevalent with the versioning side of it? You mentioned that a little earlier because there's a flow of information which is changing.
It makes the whole thing harder to understand because how the model behaves depends on the data that was recently entered into it. You have to have constant monitoring of what it does.
Hmm.
It will not do that. You look at it from time to time
That is
because
true.
it's constantly changing. Then also to understand what it did, you have to have a snapshot of everything else, right? Was it answering my question correctly because I changed the model or because the knowledge base started to have the answer? If a change happens to be at the same time of a change to the document store, to answer those questions, you have to replay the system, like replay
Hmm.
a new system at an old
Hmm.
checkpoint, right?
There you go. There you go. So that change, it can happen at the model level, it can happen at the prompting level, it can happen at the underlying knowledge base. Knowing what is impacting your final responses is going to be a challenge.
All of this is code. In machine learning system, data is code. Prompt is code. External data is code is code. So all of this has to be versioned. Just like we use Git to version source code, we should use Git to version data or something along that line.
There's some more technical questions which have come up. I'll put them towards the end. I'm also looking at the list of questions. There's a very frequently talked about, and I think we discussed it too, this concept of learning to forget. It seems to be gaining some attention. What are your thoughts on this concept? Are they related to the whole versioning thing? This, how do you make things forget? What's your understanding of forgetting in the first place? Yeah, I think the audience has a different understanding, your understanding, and then we can take it from there.
So at a very formal level, if a model forgets a piece of information, it should behave as if it have never seen it. So if you have the data with and without this information, if you train the model on the data with the information you want to forget, and then you remove it, so you force the model to forget, and you compare this to a model which has never seen this piece of information, they should behave the same way. That is a way to formalize forgetting. It's also, for instance, there is a new RIPS, deep neural net forgetting challenge. That's how they define it. Having this definition, there are multiple ways in which you can try to achieve this forgetting, right? You can retrain the model. For the LLM, for instance, you can keep the information you want to forget in the external database and never ever store it in the model, right? So separate between the information that goes through prompts. And that is easier. It's a database. You can insert, remove stuff from the information in the weights. There you hope you will be never asked to forget because there is nothing perfectly secret about it. If you start tuning the models, it will be interesting because on the one hand, neural nets have this catastrophic forgetting ability. If you train them on new tasks, they tend to forget the old tasks. On the other hand, they get to remember some statistics of the old data sets. So it may be that it forgets, but not the part you're interested in.
Got it. Got it. I'm trying to simplify it, Jan, because there's some other information which also gets forgotten because you try to forget this information. Is that how you would say it? Like a chain of...
Or you were just trying to insert new information into it without refreshing the old.
Got it. Got it.
And then going to be a question of regulation, right? How good have you been at forgetting targeted information?
Got it. Makes sense. Makes sense. Okay. Now we will go into another operationalizing question because everybody's asking, how do we get this into production? I guess everybody's tired, Jan, if you think about it, of prototyping and they know this thing is cool. Moving from cool to production is the challenge everybody's facing. I think we're probably 4 or 5 months before things get into production. So, question folks are asking are, what are the challenges, operational challenges, companies who have started on the LLM journey struggling with in the short term, which is like next 6 months, and long term, like after a year? What are those challenges?
One of them is quality assurance. Because the LLM is such a powerful tool, because you can get started with just a notebook and a few prompts, you can get close to a system which does whatever it's supposed to do in a very ad hoc manner, just by tweaking it and experimenting with it. And then, of course, you have to maintain it. And at some point, you cannot do quality assurance by having conversations with the model. You can go insane from it, right? After a while, you don't even know whether the new thing it responds is better than the old one. After a while, you have to be more principled in what are the inputs to the system, what are the desired outputs, is the system consistent on them, which means create data sets, version what goes in and out of the model, flag what's wrong versus what's correct, which really means create a training and testing desired input, desired outputs data set, and evaluate parts of the model as if it were a machine learning model. So compute some sort of accuracy, bearing in mind that local quality assurance doesn't mean that the whole system behaves in the same way. So you need to know which models are deteriorating, but also whether the system is still working correctly as a whole, because there is this interdependency.
Got it. Got it. And when you look at the old way of doing things, yeah, and I'm talking old meaning not so old, but still old compared to the whole Gen AI type apps, the ML ops side of it, right? There's a lot of work put onto machine learning ops. Do you see some of those challenges transferring over to what we're calling LLM ops now? What are those similarities and what are the maybe the differences in these kind of ops? If you can explain that, if or are they exactly the same?
I guess the fundamental challenges will be the same. The fact that you have a system built out of tiny pieces which learn to or are optimized or are exchanged to play well together makes it a system which is, in a sense, end-to-end trainable, interdependent. And engineering hates interdependency. You don't like a situation where changing something trickles down through the system and causes unexpected bugs. But this is the nature of machine learning systems, so this is inherent to the problem. Then the LLMs may hide something because you don't have to do a training set. Namely, ask yourself, what is the correct answer for this? You can just play with a couple of examples and then get the outputs. And this is awesome. It lowers the bar of sorting significantly. But in the end, this is the same. So you have to try to formalize as much as possible what is the desired outcome of my model. If you don't formalize it, then you are stuck with manual testing. And if it's not formalized to a point where another human can take over, it's even worse. How do you train your assistant to score the model if you cannot say what's the desired outcome?
And just from a testing, I know you brought that up as one of the QAing being one of the aspects. The human in the loop cannot be completely taken out. We're looking at, when you look at code at scale, especially code that has some level of automation, are you seeing this split in your eyes? Yeah, at least in the short term. Are you seeing a 50% split, 80% split, human in the loop versus some level of automation? And if so, what is that underlying system? Do you have registry for prompts? What does that mean?
I guess there will be both. Many things can be automated, and there is nothing bad about it. The problem is that up to a level, any error measure you take is correlated with the desired outcome. After a while, you start to optimize the measure. So for instance, let's take something very well defined in a sense, translation systems. The quality of a translation given the ground truth translation. There are some automatic measures for it. There is the blue score, the rouge score. They are very good proxies. The best models are not distinguishable using those two prompts. So if your model becomes seriously bad, you will see, and if your model deteriorates slightly, you will probably see it on the blue or rouge score. But beyond the point, you have to do human evaluations. Which sentences do one set of humans prefer to the other one? Then you can try to train a model to detect those two.
Got it.
In essence, what the reinforcement learning from human feedback is all about capturing this human preference, right? Building this model which captures the human preference. And then if you can tune the LLM to act the way you want, you can also monitor whether it acts the way you want using a model trained on user preference data. But this model will inevitably be misaligned with the real thing.
Got it.
So you have to monitor it, but also automate as much as you can. It's going to always be a game of chasing the rabbit, fix a little bit, and then, or peeling the onion, fix something, cry a little, fix again, cry a little.
I like that feeling down in. I've not heard that before, but that's a good one. That cry little is definitely happening already. I think cry a lot is happening now. Good, good. Let me see if I'm wrapping up in terms of the questions I've got from LinkedIn. There's one more question around just the commercial nature, making things commercially viable, especially in LLM, because you're seeing people, I don't know what the right word is, people have on their ChatGPT enabled chatbot on their website, but customers are coming in, they're using it for other things, not meant for a purchase on an e-com site. And then you're looking at your bill and they say, oh my God, I don't know if I actually made money out of this whole integration. And so that's one side of it. Like, how do you prevent some level of, I don't know if the word abuse is right, but abuse. But on the other side, we have just the fact that it's somewhat expensive still, right? Do you see that cost eventually coming down? I'm looking at some kind of correlation to Moore's law or something around that nature. Is there a LLM law?
I guess we need to take a step back, right? If you speak about costs or lowering costs, you speak about return of investment, and there is a question of return. So you can use an LLM chatbot or any LLM tool to prototype some behavior. But ultimately, this behavior has to drive business or has to drive a business metric up. And only then you can decide what to do with it. Now, chances are you will have a prototype with an undefined role, and then you will discover what this prototype is really doing, right? So this prototyping is helping my upsell. It's helping me recover from lost sales because people don't have exactly what they are looking for, but I can propose them something with better serendipity than whatever my recommender system is doing. So you start to see a function for this, and you can put a measure on it. And then only then you can try to drive costs down. Because if you know what the system is supposed to do, you can try experimenting with, I don't know, cheaper variant of it. Cheaper in the sense, let's use a cheaper language model, cheaper in the sense, oh, I have this part of the model which is trying to predict the intent, but in the end, the majority of cases have, I don't know, 5 intents. Maybe a naive bias classifier will do LLM to label data for you, essentially. But this all goes back to, you do have a log of all the interactions with the bot. You are able to
Yes.
extract for each and every part of it a training test set, and then try to replace a part of it, not by prompt tuning, right? But by a complete a replacement of the model. Maybe this part is going to function out of scikit-learn, and half of the cost is going away because you've bootstrapped. You already have the data to train the other systems.
And you
But
just
this
gave me an
all
idea. Yeah,
starts
no,
with metrics. Yes.
you just gave me an idea when you said this, when you talk about different types of, you could use one of these classifiers, for example, you said some kind of labeling. Can you, in terms of setting these systems up, can you use these, what I call lightweight models versus LLM models, and deal with it as a chat happens? Is that something you recommend, or you just say, you know what, you're dealing with LLM, just talk to the LLM endpoint, and that's good enough? Classify before you hit the model. This is what I'm asking.
I guess after a while you can. Like
Hmm.
the LLM is really good at prototyping things. But then in the end, you want to have a special built thing. Like think unrelated. Think 3D printers. Wonderful technology. Who uses injection molding? Those that know what they want to do and want to drive the cost down, right? For prototyping, the LLMs are really like the 3D printers of manufacturing. Every NLP operation you want can be prototyped in an afternoon. But then once you have the prototype and the prototype works and you see what's good and bad about it, you can try to abstract it away and invest, just like you invest into a mold for casting, or you invest into, say, a proper data set, to proper definition. But you know already that it's worth it. For some of the interactions, there will be no better technology. Obviously, the language models do way more than the classical NLP techniques could do.
Got it.
But
Got it.
maybe this is going to be 10% of your application, not 100% of it.
Mhm.
And that is the cost saving.
Nice. Very nice. No, thank you. Thanks. And that is definitely insightful, especially for me. When I was just trying to find out, eventually, when you go productionize, you have these choices, which is important for, and you need a flexible system to make sure you can make those choices in the first place, not all going into one place. Now we're going to switch into the audience questions. Some of them are pretty deep, but I'll start with the ones which have been in the audience. And I'm seeing a stream here, so I'm trying to choose the one, right? Oh, there you go. The first question from Marcel. Thank you, Marcel. Go ahead. I'm not going to repeat that, but Jan, you can possibly answer that.
Sure. So at a high level, they were fairly similar. Both had an encoder and decoder network. The main thing is that the attention was the mechanism which was gluing the encoder and decoder. What happened with the attention is all you need paper, so with the transformer paper, is that self-attention is used as part of the encoder and decoder. We were using recurrent nets or convolutional nets, and then you can think that the transformer is a generalization of both. So in a sequence-to-sequence system, you have self-attention, possibly bidirectional in the encoder, and then causal, people say the one that only looks backward in the decoder, and then the cross-attention in the middle. So those systems have many attention heads, and my system had only one. And just like the early translation system by Dimitri Bagdano, it only had one to match the decoder state to the encoder state. So it's a very brilliant application of using the same pattern all over the place, as opposed to this one place where it's really crucial to have it.
Got it. I will take a couple more questions. I'm just trying to get the next one in. There you go. The next one is from Ishan. I'll read it out. Is the current preference for attention-based transform architectures and LLMs settled, or do you foresee an emergence of significantly more advanced models in the future, which is surpassing the existing ones?
I think it's not settled. What may happen is that if you have sufficiently powerful model, the operation of the model is dictated by data. For instance, in the field of vision right now, there are convnets since the 80s. There are vision transformers. They are variants that try to merge the two. If you have enough data, they all more or less work in the same way. So you must know in which regime you work. If you work in the full data regime, you want models which generalize well. If you work in the large data regime, you want models which are able to ingest the data. A sufficiently large neural net is in essence a non-parametric model. It can ingest all the data you can put into it, given that you know how to train it. The transformers are super easy to train. They are the best scalable technology right now when it comes to ingesting lots of data. It may be that you will have another architecture which does just as well in ingesting data and is not a transformer. Just like in vision, maybe people will go back to the continents
Mhm.
just because, I don't know, it's cheaper
Got it.
or some mixture of the two.
And mixtures happening in the future too, right?
Oh,
I
yes,
mean,
yes, yes.
okay,
No,
got it.
maybe even the executive order that the US president put up right now will pour some more research into it because they try to define the critical mass by the number of parameters and floating point operations. So
Mm.
if you do models which are cheaper on those, or I don't know, don't do floating points but integer, and suddenly they will bypass the executive order,
There you go.
and this will be the spark for this.
Got it. Got it. And I wanted to give a quick shout out to Ishan because Ishan is somebody who has led the boot camp at
Oh,
IIT Bombay.
nice.
And he's
Nice.
not just a practitioner, he's also a great leader, getting all these questions answered on your behalf, Jan, on behalf of Pathway. So he's been doing an amazing job. And the kind of questions he's been asking and supporting has been phenomenal. I'm more than happy to, Ishan, you have a direct access to Jan. So you can have a private chat with Jan around any questions around his code.
Sure,
You
sure,
can
sure,
be
sure.
you're more than happy to accommodate that. And especially other students too. Just feel free to come on to Discord, ask questions, and challenge our thinking. Does not mean that we know all the right answers. There are different ways and trade-offs, like Jan would point out, in terms of how we make calls around LLMs. There's a question around LLM ops. Now, there you go. Milin's asking this question around at what stage do you see LLM ops being necessary? Obviously, a lot of these startups are doing prototyping, and then when do you see the formalized kind of LLM ops happening?
Well, it's a great question. But even if you do hypothesis testing, you're probably saving your hypothesis somewhere. So it's part of versioning, right, of what have we tried. Maybe if you're just trying 10 different ideas and see whether people react to one better than the other one, the prototyping and kind of teaser quality is enough. But then when you hit the one that you want to work on, is going to be more needed. It's all about the desired output. Do you know what you want to build and you want to build it efficiently, or are you still searching? And then you want the quick experimentation, right?
Mm-hmm.
Going back to the 3D printer analogy, maybe you can sculpt it out of clay, right?
There you go. You don't
And
need to print.
that works. The car industry was doing it for a while. Clay sculptures scales pleasingly well.
Yeah. Good. Let me see if there's any other question. I think we'll wrap up with maybe maximum of two more questions. Just trying to pick it up from the stream of questions here. Okay. There was a question around AGI model. There you go. Why do you think language focused models ended up using the AGI model instead of CNNs? Does language contain something special as opposed to vision?
The first question in the implied thing is that we believe that this is the AGI. I don't know whether it is.
Yeah, and for the audience, not everybody knows AGIs and CNNs. If you can break it down, baby step for us.
AGI is artificial general intelligence, and
And
CNN is
CNNs.
convolutional neural net. I will not be answering whether we have ended up with the AGI or no. What language contains special as opposed to vision? We use language to communicate higher level concepts. We do talk right now, you can close your eyes, we can have a meaningful conversation, there is no vision going into you, right? So as humans, the most complex things we can have, which are our thoughts, we learn to serialize them using language. So if you build models which deal with language, in a sense, the complexity of things you're dealing is the complexity of human thoughts. The only way that I can transmit a thought of mine to you is through language. Human language is capable of conveying the most critical information, the most complex information. And in a sense, is the ultimate medium, right? Any single question you may have, you can probably write it down and expect a model that will write back to you to answer or no. Vision doesn't have that. Now, that being said, probably maybe convolutional networks, huge convolutional networks on text would do just as well. I guess it's more of a technicality that they don't. Namely, convolutional networks are super sensitive to where things are. In language, it is very easy to introduce some filler words, right? You do the disfluences, right? You have to jump over them. Convolutions cannot really do it. Attention mechanism can. It's very similar to a convolution in a sense. Maybe that's this. On images, shifting by 4 pixels is meaningful. In language, shifting by 4 tokens is not meaningful. And the attention is better at this.
Thank you for breaking it down. Appreciate that, Jan. I think we'll take one last question and then we'll wrap this up. There's a stream of questions to come up. Is one around accuracy? Okay, there you go. Can LLMs be used to generate scientifically accurate and engaging explanations of complex phenomena for educational videos targeting a wide audience?
The answer is probably yes.
Hmm.
But I guess the answer to most things which start can LLMs be used to is probably yes. They are good at paraphrasing information, good at explaining things. So as a tool, yes. As the sole technology without any human supervision, that's a lot of trust. But then companies need supervisors for a while. Humans cannot work with supervision to an extent. I don't know to which degree the concepts that you feed into them need to be common to them. In a sense, all the tests you do right now for the scientific concepts, they were all in the training set. For most of the interesting scientific concepts, you will have many blog posts, explanations, textbooks, and it's hard to say whether the LLM gives you the explanation that someone gave
Mm-hmm.
or does something novel.
Right.
I don't even know how to go about trying feed truly new concepts into LLM, but probably you can by some description, some bootstrapping on what it knows right now.
Got it. Got it. No, thank you, Divya, for that question. I think, like I said, even though I said it's last, there's one more. Noor Hassan, thank you for asking this again. And we'll stop by this. This is the last one. Yeah, and I promise. And then we can obviously take all the questions later offline.
Mm-hmm.
Please feel free to ask those questions on the LinkedIn page where the webinar is already hosted. You can ask those questions. One of us, for sure,
Mm-hmm.
will get back to you, either on LinkedIn itself or at our personal DM message. Noor is concerned about costs. I know that. And that's a question I asked a little earlier. How can I reduce the number of tokens consumed by my Pathway LLM app when interacting with OpenAI by sending my full context only once and then reusing it for subsequent queries? I know you have quite a few thoughts around that. Jan, go ahead.
Well, in this case, if they have a function to send the context and then use the starting point for many other queries, then you want to have a stateful application. So something which has a table of conversations and context and then does a join on it with the current conversation. And then you feed this context identifier as opposed to the context text. It's slightly more complex because so far the LLM app was built as a demo where the conversations are separate from each other. The rounds of conversations are separate.
Got it.
Now you're
Got it.
introducing a codependency. One of them introduces a context for the first time and the other ones reuse it.
Got it. Got it. Might be worthwhile looking at that specifically as an item you could raise a Noor on the conversation within GitHub, Discord, or even as an issue, and we'll address it as a possible item. Great. Thank you so much for today. A lot of you, like I said, have come in pretty late in different time zones. And a lot of you have taken some time off from work to listen to Jan and his thoughts around LLMs and where we are going, or generally where we are kind of pain points addressed, operational issues addressed, and topics around cost and efficiency of LLMs too. So thank you for the time. And we'll wrap this up today. And again, please continue asking questions on the LinkedIn page itself. Appreciate it. Take care. Thanks, Jan.
Thank you.
Take care.